Hey guys, welcome back. This is Abhishek again, and welcome to my YouTube channel. Welcome to N.L.P playlist as well. So today in this video, we will be talking about spaCy library. So spaCy, if you have never heard of spaCy, so don't worry. I will be discussing everything from scratch, and this is very popular library used in natural language processing. So this works same as NLTK. So before further wasting any time, if you haven't subscribed my channel, Abhishek Jaiswal, you can find me on YouTube, and you can subscribe my channel. And if you like my video, please share and subscribe. And I upload data science machine learning related videos each and every day. So you can subscribe my channel if you like. So before doing, let's start. Before further wasting any time, let's start. So we are going to discuss spaCy. So what will we discuss in this notebook? So spaCy used for tokenization, lemmatization, stop word removal, punctuation removal, name entity recognition, parser, part of speech, dependency parser, and data cleaning. So spaCy used for all these features. spaCy used for all these features, and I will be discussing each and every features in this notebook. So before doing anything, let's first install spaCy. If you have never used spaCy, you must install first. So how would we install it? By executing this command pip install spaCy. So I would always prefer you to install it from your notebook cell by using exclamatory sign, because when you install any library from command prompt, there could be any other Python path that could be installed, and any other Python path. So that's why I always recommend you to install spaCy by executing Jupyter command. Okay, Jupyter cells you can install from there, and it will be always loaded, and no, there would be no any import error, and that's why I would suggest you to install from here. Okay, second thing, so after installing spaCy, it's not enough. Okay, spaCy used for so many languages. spaCy can be used for German, French, Russian, so there could be any other language, right? So for that reason, you have to specifically you have to install English language if you are working on English language. So in English language, there is three type of body text body or vocabulary available for spaCy. One is small, second one is medium, and third one is large. Okay, so right now I'm using small version. So how to download vocabulary? So what you have to do, you have to run this command, uh, python m spaCy download n core web small. So you can use small vocabulary, you can use medium vocabulary, you can use large vocabulary. They comes with different size, they come with different size. Small vocabulary comes around something 20 MB, medium is somewhere around 70 MB, and the large vocabulary comes somewhere around 700 MB. So as you use a large vocabulary, your efficiency will be much higher. If you will use small vocabulary, your efficiency will be accuracy will be low. So I would always prefer you to go with medium vocabulary size, because it always gives you not good not bad. Okay, it gives you almost efficient and accurate result. So you can run this command. So right now it will take much time, because it have to download 40 MB, so it will take time. So that's why I stopped this cell. Okay, second thing, after installing spaCy and after installing vocabulary, what you have to do, you have to load vocabulary in your spaCy and make a pipeline. So how would we do that? So what you have to do, just import spaCy and NLP equal to, I have just given a name, NLP equal to spaCy dot load, and here you have to pass vocabulary name. En means English, core, web, MD means medium. So you have to just write this name right here and just run this. Okay, so what it will do, it will make a pipeline. So how pipeline looks like, let me just show you. So what spaCy pipeline would be like, this is a pipeline. Okay, here would be so many words, and in spaCy pipeline we have three type of um, operations right here, uh, tagger, parser, and name entity recognition, right? So we have three type, and this is something like pipeline. Here we pass our text, and after doing some pre-processing by by spaCy, we get our words. Suppose we pass here a sentence in our pipeline, so this pipeline does everything and return our tokens, right? So whatever operation we want to perform, this pipeline will do for us. So here N.L.P is a pipeline, so I have given a name. N.L.P is a pipeline, so you can see spaCy language English, and this is our pipeline. Okay, so first thing, let's start. uh, so let's start our tokenization. So I have written a word here. So India spent 2.5% of GDP on their defense budget. So many people think that tokenization is just splitting on their spaces. So if you will split, you would get 2.5% as a token, GDP as a token. So but this is different, right? So what we will do here, we had created a pipeline named N.L.P. So in that N.L.P, I have to pass our text data and just run this. Okay, if you want to see what doc returns, so you can see that this is our something. We can see that this is our string which we had passed. But what if I write to list and doc? No, it will be only list doc. If I run this, then you will be able to see that we are getting every tokens by this text. Here India spent 2.5 and percent are different tokens. So you can see here, and if you want to print them, you can, what you can do is for token in doc, print token, so you will see all the tokens, right? So this is tokenization by using spaCy. You can do any operation. You can use apply method, you can use lambda function for tokenization by using spaCy. It depends on you, it's totally up to you how you use this tokenization function, right? So the second thing is removing stop word by using spaCy. So it's again really very simple. What you have to do is, since we have here doc is an object, doc is an spaCy object. Here N.L.P is our pipeline, and here text is our data, right? So what we had done here, so you see that doc is our, let me just show you what doc is our N.L.P object. Doc is our spaCy object, you can say that. Okay, for removing stopword, what you have to use, it returns token, and in token if you use this method is stop, means is stop word. So for removing stop word, what we have to do, token for token in doc, if not token is stop. Okay, token is stop means token is a stop word. So if you filter this, so you will see there is no stop word, like we have no on and all these. So here what stop word is, stop word means on and all these. So if I add uh, on the GDP, right? So if I add the, and now our text data is something with the, and now you will see that we have no the, and that's why. So if you use token is stop, means it removing stop words, right? So in the same way you can remove punctuation as well. So for punctuation you have to use token is punct. So if you use token is punct, if token is punct will be true, then we would ignore that. Okay, so if I run this, so you will see that we have no percent sign here, because percent sign supposed to be a punctuation, and that's why we have no punctuation right here. So in this way you can remove punctuation as well. So for limitization, what you have to do here, text equal to, I have taken a text. So if you don't know what limitization is and what stemming is, stemming and limitization, the process of stemming is just like, we have a word like barking, so we just drop that ing and it will be bark. Standing means just drop ing and it will be stand. So lemmatization is a process to convert any word to their root word. Okay, so lemmatization is a process to convert a word into their root word, because there could be so many words made by a root word like stand, standing, stands out, and all these things. So that's why lemmatization is used to convert any word to their root word. So right now I have taken here dog is barking at the human who looking uh, scariest, right? Who looking very much, suppose very much scariest, something like this. And here I have passed this text into our NLP pipeline, and here I got document. So document is a collection of text, right, and collection of tokens. What you will see that document is a collection of tokens. So here for token in doc, print token, and here I have given some visualize, and then token dot lemma. If I use token dot lemma, lemma is a method to for lemmatization. So if I run this, so you will see that here you will see that here dog is barking become bark, and here you will see that scariest becomes scary, and very much looking becomes look. So every verse, as you can see, every word has been converted into their root word. So right now let's see what dependency parser is, because it's really very important. So in any sentence there could be so many words, and each words can be related to other words, right? So this is called dependency parser. In a sentence the word have a relation with each other. The one word is in a sentence which is independent of other is called head. Means the word in a sentence which is totally independent is called our head or root word. All the other word are dependent on the root word, and they are term dependent. So we have get we used to get some encoded value like n subject means subject of the sentence, root means root word or head word, prep means prepositional modifier, and cc or conjunction, it could be linkage, is an, or. And this is pobz means a preposition auxiliary verb, and dobz means our direct object of the verb, and dt means independent word. So right now I am creating a pipeline right here, and then I have just taken a sentence right here in my text, and I have passed this my text into our spaCy pipeline. And what I have done here, right now here my document is a collection of token in this case. So for token in my doc, token and token dot dep. So in lemmatization we had used lemma and followed by our underscore. For you doing dependency parser, what you have to use, you have to use dot dep underscore method for dependency parsing. So as you can see here, ardra is our subject, fell is root verb, like fell is totally independent to other word, into means preposition, a means determined, well is p obj, you can see here preposition, and her leg and all these things, so you can see from there. Okay, if you wanna plot these things, so you can plot that as well. So for plotting what you have to do, from spaCy import displacy dot render, and you have to pass your document here, right here, and then style equal to dep. For plotting for plotting dependency parser, you have to give style equal to dep and jupyter equal to true. And if I run this, uh, if I run this, you will be able to see my doc is not defined. I have to run this, sorry. So you will see that we have got a plot right here. It's too big. I forgot to change the size of this plot, so it doesn't matter for now. So now at the stage we are going to discuss part of speech tagging. What part of speech tagging is in every sentence, giving the word. There are so many words in a sentence, and each word can have part of speech. So we have to just describe their part of speech of every sentence. For example, Geeta is dancing. Geeta is a person. Dancing is a verb, and Geeta is a noun, dancing is verb, and all these things. So you have to give the part of speech for every word. For doing part of speech, what you have to do, I have given a name right here. Taken a sentence, text equal to Nitika was screaming out loud. As usual, her roommate kept ignoring her. Then you have to pass this text in our natural language processing NLP pipeline. And I have given a text doc. And what text doc will be? Text doc will be list of tokens, right? So for token in text doc, token dot text dot just I have used. And then you have to use token dot pos means part of speech, followed by underscore. And if I run this, so you will get each and every word with their part of speech. Nitika proper noun, was auxiliary, screaming verb, out loud usual, roommate noun, ignoring verb. So everything right here you can see with their part of speech. Okay. So sometime, this is really very important when you do topic modeling and summarization of text data, because in topic modeling and summarization of text data we don't consider preposition, auxiliary verb, and all these things we don't consider. So by using part of speech tagging we can filter that type of things, right? So at the end we are going to discuss name entity recognition. So what name entity recognition means, in any sentence there's we have to give what word means, right? So sometime means India is a country, Google is an organization, and so everything you have to just define which word means what. So this is called name entity recognition. So this is very simple. And so what I have done here, I have taken a sentence. The building is located in London. It is the headquarter of Yahoo. John worked there. He speak English. So I have taken a sentence and I have passed the sentence in our NLP pipeline. And then there is little different, right? So what you have to do here, for entity in doc.ents, doc.ents will give you a list of entity. And then what you have to do, I have given entity.text, and here I have given ner name, and then entity.label followed by underscore, and this will give you entity name and with their text. So London is group of country, Yahoo is organization, English is language. So you can see that London has recognized, Yahoo has recognized, and English has recognized. And if you use your big vocabulary, large vocabulary in your spaCy, so it will be more accurate. So for plotting you can use from spaCy input displacy.render document. You can pass your document, and then style for name entity recognition you have to give ent and Jupyter equal to true, and you will be able to see this nice text here. Every word has recognized with their group. London, GP means group of country, Yahoo organization, English language. So in this way you can do all these things. So in the next video we will discuss more about spaCy, more advanced thing about spaCy. Thanks for watching this video. If you have liked this video, please subscribe my channel and comment me if you have any doubt. And don't forget to download this notebook. It will be given in description. Thanks for watching this video. Have a nice day.